Hello everyone. Today we're in York, or Jorvik, the ancient capital of Viking Britain. The great heathen army led by Ivar the Boneless arrived in York in 866 and quickly took over from the Northumbrians, who were busy fighting each other. The Vikings, one of the great seafaring cultures, got all over the place, from Canada to Ukraine. But how did they navigate from the frozen wastes of Scandinavia to the frozen wastes of northern England? For 250 years, the Vikings dominated the Baltic Sea, the North Sea, and even became the first people to sail across the Atlantic Ocean. Navigating by coastal landmarks is one thing, but crossing open water is much more difficult and dangerous. The world's great ocean navigators all used a variety of techniques, navigating by the sun and the stars, and by paying attention to environmental cues, patterns of wind and waves, the movements of whales and birds, and seeing how clouds cling to the land. But the Vikings may have had something extra up their sleeves. According to Norse myth, Vikings possessed a sunstone, a type of crystal that could point to the sun when the sun was not visible, when the sky was overcast or snowy. In the saga of Saint Olaf, also called the story of Ralph and his sons, King Olaf visited Ralfalfr and his sons Daga and Sigurður. The king demanded to know what each person's special skill was, and Sigurður claimed to know the stars and was able to reckon time. The next morning, when it was overcast and snowing, the king asked Sigurður how far the sun had travelled. To check Sigurður's answer, the king had a sunstone held aloft and observed where it cast out a beam. The altitude it showed was exactly as Sigurður had said. The saga of St. Olaf is primarily the story of Nebuchadnezzar's dream, lifted wholesale from the biblical book of Daniel. But the sunstone part is pure Norse, and it's the clearest mythical description of how sunstones were used. Sunstones were great treasures owned by kings and bishops. The story of Bishop Gudmund the Good tells of a raid on the coastal town of Ir, in which treasures were looted, including a sunstone. In 1967, Danish archaeologist Dr. Thorkild Ramsky proposed that the Viking sunstones may have worked the same way as a twilight compass. The twilight compass is a device invented by the US Navy in 1948 and used by pilots flying near the North Pole, where magnetic compasses become erratic. Light rays have a vibrating electric field. Polarization is the direction of that vibration. Light direct from the sun is unpolarized, but scattered light is polarized. That's why polarized sunglasses can block glare. Light scattered from the surface of the sea or a snowfield is horizontally polarized, and sunglasses are vertically polarized. Liquid crystal displays are polarized as well, so sunglasses can also be used as ad blockers. Skylight that's been scattered by the atmosphere is polarized. The more the light has been bent, the more polarized it is, and so different parts of the sky have different polarization. The twilight compass works by measuring the polarization of skylight and using that to work out the direction of the sun, even if the sun is below the horizon, close to dawn or dusk. Many insects, including bees, have polarized vision. When bees find a source of food, they return to the hive and tell the other bees where it is using a waggle dance. The angle at which they perform the dance is the same as the direction of the food source relative to the sun. Ramsky suggested a couple of different minerals that could have been used as sunstones. Cordierite is pleochroic, which means that the crystal changes color as the polarization changes. Cordierite and andalusite, another pleochroic mineral, are found in Norwegian beach gravels, but large crystals are not found in Scandinavia. Calcite, sometimes called Iceland spar, is strongly birefringent. Horizontally polarized light takes a different path through the crystal than vertically polarized light, producing two images. Rich veins of optical calcite have been mined in Iceland. How might Viking navigators have used Iceland spar to find the sun? If you place a spot of tar, charcoal, or blue tack on one face of a sunstone crystal and look through it, you'll see two dots. If you look through the crystal at a source of unpolarized light, like the sky close to the sun, you'll see two images which have the same intensity. Half the light takes one path and half the light takes the other. Looking at a source of polarized light, like a patch of sky away from the sun or a computer monitor, what you'll see will depend on the orientation of the crystal. The short version of the story is that if you look straight through the crystal at a patch of polarized sky and rotate it so that the two dots have the same intensity, then a pointer sitting alongside the crystal will point at the sun. The theory is not quite right because the cleavage angles of calcite are not right angles, so the pointer is always 6 degrees off, but the offset is consistent and so can be compensated for. If you can do this at two clear parts of the sky, you can imagine two lines across the sky that meet where the sun is. Line that up with your sundial, and now you know which way north is, or more importantly, which way west is. No Iceland spar crystals have ever been found on a Viking ship, but one has been found alongside other navigation equipment on an Elizabethan ship that was wrecked off the coast of Alderney in the English Channel in 1592, 500 years after the end of the Viking Age. Magnetic compasses were in use by the 16th century, but magnetism wasn't well understood. Deviations from true north and local anomalies caused confusion. Magnetic compasses also suffer from deviation when they're near ferromagnetic objects, and this could well have been a problem on the Alderney ship, given that the whole point of the voyage was to take large pieces of iron to France. An optical compass may have served as a useful backup when the magnetic compass was a bit iffy. Once again, animals beat us to it. Migrating songbirds use the Earth's magnetic field to navigate. But birds, like the savanna sparrow, which migrate to Canada and Alaska, where magnetic declination changes a lot, can use the polarization of skylight at sunrise and sunset to recalibrate their magnetic compasses. Vikings commonly navigated by sailing directly west. Greenland was serviced by ships that sailed due west from Hernum, now Bergen in Norway, to Hvarf in Greenland along the line of 60 degrees 20 minutes latitude. An artifact discovered at Uunartok in Greenland may be part of a sun compass used for this kind of navigation. Because the sun appears to move across the sky, the position of the sun by itself doesn't tell you which way to sail if you don't know what time it is. The lines inscribed on the disk may have been used to track the length of shadows during the day. When the sun was not visible, a shadow stick may have been used with the sunstone to perform the same task. Other investigations suggest that the disk may have been used with sunstones around twilight. It's only a fragment and it didn't come with instructions, so we're not really sure. Tooling around the North Atlantic in an open boat to test speculative navigational theories can be cold, wet, and miserable, with a chance of fatal. But there's plenty you can do in a nice warm office with a laptop. Researchers have calculated how well sunstones work in different weather conditions, given the polarization of the sky, and how well people can estimate the position of the sun with the tools described. They've also made thousands of simulated trips across the Atlantic, taking into account various levels of cloud and other sources of error. If bearings are taken often enough, say every 1 to 3 hours, these navigational techniques work very well. If bearings are taken less frequently, you can either freeze to death in the North Atlantic or discover Canada. On the return trip, things are even better. In the worst case, you hit Ireland and have to hang a left. Navigating by polarized skylight. The birds and the bees do it, and apparently the Vikings did it too. From slightly iffy beginnings, as a weird detail in a second-hand Bible story, the magic stone that can find the hidden sun looks as if it was probably real, despite a lack of archaeological evidence. The Vikings used the birefringence of Iceland spar and the polarization of scattered sunlight to navigate the icy waters of the North Atlantic and become early Europe's greatest ocean navigators.